Hello everyone, welcome to 10-Minute Physiology. In today's video, I'm going to give you a short explanation as to what isotonic contractions are and what they can teach us. So with that, let's give it a go. So I'd like to start off by first telling you what an isotonic contraction is. So in order to understand, imagine you have a skeletal muscle, and this skeletal muscle is attached at one end to an immovable object, and the other end is attached to a load or weight. Now let's say we take a stimulus and we stimulate the muscle, which causes it to contract, and when the muscle contracts, the muscle shortens and it brings the weight up. Now this right here is an isotonic contraction, and this is because an isotonic contraction is a contraction that occurs when a muscle has a constant load. Now, since we know what an isotonic contraction is, what can we learn from them? So the first thing that we're going to address is how much force is generated by this muscle during the isotonic contraction. So let's take a look. So this computer here shows us how much tension was generated by the muscle during the contraction. Now, the main point that you have to look at is how much the load that was attached to the muscle weighed. So the load is going to weigh around this much. So this is going to be the weight of the load. So now, since we know the weight of the load, let's take a look at what the contraction looks like in terms of force generated. So this graph right here shows us the amount of force that was generated by the muscle during the contraction. And what we see is that the contraction starts around here, and the tension generated by the muscle gradually increases until it gets to this point, the peak tension. So the peak tension is the point at which the tension generated by the muscle is equal to the weight of the load. So in other words, the tension increased in the muscle until the tension generated by the muscle equaled the weight of the load. And after it reached this tension, no extra force was exerted by the muscle. So this right here is telling you a specific point that the tension generated by a muscle, if it has a load attached to it, and if the muscle is able to lift that load, the amount of tension generated by that muscle is going to be equal to the weight of the load. So now that we know this point, let's look at the second thing that we can learn from it. And the second thing is the relationship between the initial velocity of shortening and the weight of the load. So let's take a look. So this computer shows the relationship between the initial velocity of shortening and load. So what we're going to do is we're going to take a skeletal muscle and we're going to attach different size loads to it. And what we're going to do is measure how fast the muscle shortens with each of these different loads. So when we do that, we get something like this. So what this graph tells us is that as the load increases, or as the weight of the load increases, the initial velocity of shortening decreases. Now, the important thing to remember about this is that this graph right here is taking place at the optimal length of the muscle. So for those of you that don't know what this is, muscles have different lengths that produce different amounts of force. And in general, for every single skeletal muscle, there is going to be a certain length that the muscle can be stretched out to, in which the muscle is going to produce a maximum amount of force. So if you don't know the relationship between length and force production, I'd highly advise you to go check out my video on isometric contractions, where I talk about that in detail. And I'm also going to put a link at the end of the video that will bring you to that video. So what we're going to do is see how the velocity of shortening varies based upon the differing lengths of the muscle. So how is this velocity of shortening going to be affected at different lengths when we start moving away from the optimal length of the muscle? So when we start doing that, what we see is something like this. So what we see here is that these two lines represent two different lengths. And what we see here is that this is the optimal length. This is a certain distance away from the optimal length, and this is a greater distance away from the optimal length. And what we see from this is that as we move away from the optimal length for any given velocity of shortening, a muscle closer to the optimal length develops a greater tension than those further from the optimal length. So in other words, as you start approaching the muscle's optimal length, what happens is that the muscle can produce a greater amount of force for a certain value of velocity of shortening. So in other words, as you get closer and closer and closer to that optimal length of the muscle can produce a greater amount of force for any given value of the velocity of shortening. So another thing that we notice here is this quantity Vmax. So Vmax is basically the maximum velocity of shortening a muscle can accomplish. And what we see here is that the maximum velocity doesn't depend upon the length of the muscle. It does not depend upon the length of the muscle. The only thing that it's dependent upon is the type of muscle. So the specific type of muscle is going to determine the maximum velocity. And the maximum velocity is going to occur when the load is going to have a weight of 0. So these are the main points that I want you to get from this experiment. So in summary, we talked about what an isotonic contraction is. We talked about what force looks like during an isotonic contraction, so how much force is generated during an isotonic contraction. We talked about how velocity of shortening and weight of the load are related to one another. And lastly, we talked about how Vmax is determined by muscle type. So I hope this video helped you understand what isotonic contractions are, and I hope to see you in the next one. Thanks for watching, and I hope to see you next time.